Hello students, welcome to Educate. Let's continue with physics of class 12. In previous lecture, we have studied basic concepts and Coulomb's law. Now, we are going to analyze another example of NCERT textbook. Example is given here. There are three charges placed on the vertices of an equilateral triangle. So this charge is negative, other two charges are positive. We have to find out net force on any charge. So let's see the situation. Suppose we take here minus q, here plus q, here plus q. This side is L, this side is L, this side is L. So each angle will be 60 degree. So suppose you want to find out the force on this charge at point A. So this is positive, this is negative. So if we assume that this charge is fixed, then force means motion of this charge will be in this direction. So we can say F1 will act in this direction. Now, if we consider this charge and this charge, and we fix this charge, then motion of this charge will be in this direction. So this is F2. Since separation and magnitude of the charges are same, so in magnitude F1 must be equal to F2, and if we evaluate force here F3, that will also be F3 in magnitude. Say each is equal to F. Now here, if this angle is theta, theta is 60 degree because this is equilateral triangle, so this angle will be 120 degree. So there are two forces of magnitude F acting at an angle of 120 degree. So resultant of these two forces can be found. F resultant will be root of F square plus F square plus 2F square into cos 120, that is minus half. So ultimately we will get F. So resultant will be F, and it will be in between the two forces because they have equal magnitude. So you can say this angle will also be 60 degree. So from this line, the resultant will make angle 60 degree. So we have found the net force on the charge lying at A. Now suppose we want to find out force at this charge. So what happens? In this case, we assume that this charge is fixed. Then we will see what is the direction of motion of this charge. So definitely it will move in this direction. So say this is F1, and if we assume that this charge is fixed, then we consider the motion of this charge. So definitely it will move in this direction. Again, this angle is 120 degree. So same result we will obtain. Magnitude of force is same. It is F. It is F. So resultant will be F resultant will be equal to either force, and its direction will be in between the two, that is 60 degree from F1. So this is how we can evaluate. Now consider the force at this charge. So I am redrawing the diagram. Suppose you know that this angle is 60 degree. Here charge is plus q. This is also plus q. And here there is minus q charge. So we have to consider the motion of this charge this time. So this is fixed, this is negative, so it will move in this direction, and here due to this charge, so it will move in this direction. So there will be two forces whose magnitudes are same, F and F in magnitude, and they are acting at 60 degree. So this time F resultant can be found by applying formula. So F square plus F square plus 2f square into cos 60 degree. And if you remember, cos 60 is 1 by 2. So we will get 3f square, which gives f root 3. So we have got the, and its direction will be in between the two, means at 30 degrees, so that will be perpendicular bisector of the baseline like this. So here, let's see in textbook what is given. So solution is, here they have evaluated this. It is not necessary to evaluate. Evaluation is simple because length is given as L, both charges are Q. So any force will be equal to Q square upon 4 pi epsilon naught L square. And then here same thing is given, and total force and charges will be this much. It is interesting to see that the sum of the forces on the three charges is 0. If you find the net force, the result is not at all surprising. It follows straight from the fact that Coulomb's law is consistent with Newton's third law. So to every action, there is equal and opposite reaction. So we will analyze this aspect later on. Now we are going to study what is electric field. So we have seen the expression for force, that is F equal to 1 upon 4 pi epsilon naught Q1 Q2 divided by R square. Now here, if we assume that Q1 is test charge Q0 and Q2 is equal to Q, then F can be written as 1 upon 4 pi epsilon naught Q0 into Q divided by R square, or F upon Q0, which is electric field, will be Q upon 4 pi epsilon naught R square. So expression for electric field is Q upon 4 pi epsilon naught square, and that can be found by dividing force between two charges by test charge. So it is also a vector quantity, and its direction will be away from positive charge and towards the negative charge. So we will see that here same thing is given. So this is positive charge, so direction of field is outward. This is negative charge, so direction of field will be inward. And the relation, as I have told you, that F upon Q gives electric field. Now, unit of electric field, if we find, so electric field E equal to F upon Q0. So F is measured in Newton and divided by Q0 measured in Coulomb. Here also there is another relation, like if we start from force, F equal to Q1 Q2 divided by 4 pi epsilon naught R square. If we reduce one charge, so here if we write F upon Q, so we will get Q upon 4 pi epsilon naught R square. So this time we have got electric field. We started from force, we got electric field. Now further, if electric field is multiplied by distance, then 1 R will get reduced. So we will get 4 pi epsilon naught R, and this is equal to voltage, potential difference. So in terms of potential difference also we can write the unit of electric field. So E will be equal to V upon R. If we write the units, so we can say volt per meter. So there is another unit, the same thing is mentioned here, an alternate unit is volt per meter. Will be introduced in next chapter when we will study about potential difference. So you have understood the basic concept. Now we are going to see electric field due to system of charges. If there are a lot of system of charges, then electric field at any point can be found by summing up the electric fields of all charges. So we will do some questions based on it to justify this concept. Here same thing is given. Here there are many charges and you want to find out electric field at certain point. Then one thing that is important, you have to take into consideration of nature of charges. Suppose one charge is here, say 2 microcoulomb, and suppose there are 3 charges, you can say, along the same line, and one charge is here, say minus 3 microcoulomb, and this is 4 microcoulomb, and there is certain separation. And at this point, suppose you want to find out electric field at point P. So this is positive. At this point you want to find out, so its direction will be like this. This is also positive charge. If distance is suppose x, so we can find, say, E1 is equal to 4 into 10 power minus 6 divided by 9 into 10 to the power, sorry, it should come in numerator. So E equal to Q upon 4 pi epsilon naught R square. So 9 into 10 to the power 9 into Q is 4 into 10 power minus 6 divided by separation square. Here we have taken just x. So write x square. So this is E1, means here electric field at point P due to this 4 microcoulomb charge. And then consider this. Suppose this distance is y. So electric field at the same point will be equal to 9 into 10 to the power 9 into 2 into 10 to the power minus 6 divided by y square. Its direction will also be in the same direction, means it will be like this, first and second. So they will add up. Now, due to this charge, suppose this distance is z, then you will find out E3, and that will be 9 into 10 to the power 9 into 3 into 10 to the power minus 6 divided by z square. But its direction will be just opposite in this direction. So if you want to find out net electric field, then these two are directed along same line, means they are in same direction, so they will get added. So your answer will be E1 plus E2 minus E3. Here in terms of vector, if we write, so it's okay. There are different charges like Q1, its field is E1. There is charge Q2, its field is E2. Charge Q3, its field is E3. And Q4, its field is E4. Here we are assuming that all charges are of same nature. If nature will be different, then direction will be different. Now, if you read the physical significance of electric field, so like you may wonder why the notion of electric field has been introduced here at all. After all, for any system of charges, the measurable quantity is the force on a charge, which can be directly determined by using Coulomb's law and superposition principle. Then later on, you will understand the basic concept behind it. I'm not going to explain, you can read it. Sorry. Now, we are going to see one numerical based on it. Here, the plates are shown. One is negative plate, here minus charge, here plus charge, and here there is one electron. So electron has negative charge, so it will move towards positive plate, and separation between the plates is given. Suppose this is D. So you have to find out the time in which the electron will reach to this plate. So let's read the question first, then I will tell you how to solve. An electron falls through a distance of 1.5 meters, so separation is given in a uniform electric field of this much. Field is given, and the direction of the field is reverse, keeping the magnitude uncharged and proton. First we have to calculate the time for electron and then for proton. So now first of all we have to find out we imagine that electron starts from rest. So initial velocity u equal to 0. Now we have to find out what time it takes. For that we need acceleration also. So if you apply formula F equal to ma, and you know that force is given by charge times electric field, so QE equal to ma. So acceleration can be found from here, QE upon m. And then we can apply the formula S equal to ut plus half at square. S is given in our question 1.5 centimeter. So you can write 1.5 into 10 to the power minus 2. Initial speed is 0, so keep it 0. Acceleration you have as QE upon m. Q means charge on electron, 1.6 into 10 power minus 19 into electric field is given as 2 into 10 power 4 divided by mass of electron is 9.1 into 10 to the power minus 31 into t square. You have to find out t square, so you can easily evaluate. Shift these terms in denominator to this side and then divide by this and take square root. You will get time. I am not evaluating. Now, second case is also given. In this case, motion of proton is shown. So again, same thing you can do. Same situation is there. Suppose proton is here and it moves through distance 1.5 centimeter. This time again you have to find out the acceleration. So A will be QE upon m. QE charge on proton is same as that on electron, 1.6 to the power minus 19 into electric field has value 2 into 10 power 4 divided by mass of proton. In our question, if it is not given, then you can take 1.67 into 10 power minus 27 kg. And then you can apply same formula as you have done in case of electron. S equal to ut plus half at square. So u being 0, acceleration you can get from here, time you have to find out, and S is given. So question is simple. Here calculation is done for you. They have not done the calculation, just they have put the values directly. So calculation is your part, you can easily calculate. Now we are going to see next thing. Here there is another question. Question is 2-point charges Q1 and Q2 of magnitude 10 power minus 8 and 10 power minus 8 respectively are placed 0.1 meter apart. Calculate the electric field at point A, at point B and at point C. This is little tricky question, but you can do it. It's not tough at all. So you have to find out electric field at point A. For this purpose, this is positive charge. In our question, Q1 is 10 to the power minus 8 positive, whereas Q2 is minus 10 power minus 8. So one is positive, another is negative. So here you can do one thing. If this is negative, this is positive. So at this point, if you want to find out electric field, so due to this charge, field direction will be like this. You can calculate by using formula E equal to Q upon 4 pi epsilon naught R square. Value is given, R is 0.05 and Q charge is given as 10 power minus 8. Now, due to this charge, this is negative charge and you want to find out electric field here, so its direction will be same and the value will also be same. So total field at this point will be double of the field due to any charge. So this can be easily done. Now, as far as electric field at point B is concerned. So where is point B? So point B is here. So at this point, you have to consider the field due to this charge. So this is positive. So due to this positive charge, field will be in this direction. So we can calculate the field. So suppose we denote it as E1. So E1 will be in this direction and its value Q1 is say 9 into 10 to power 9 into 10 power minus 8 divided by separation square. So 0.05 whole square Newton per Coulomb. This is electric field at point B due to charge Q1. Now you have to find out electric field at point B due to charge Q2. Since this charge is negative, so field will be directed like this. So we find E2 and that will be equal to value of charge same 9 into 10 to the power 9 into 10 to the power minus 8 divided by what is separation this time. So triple. So 0.15 square and its direction, it is toward left, so it will be toward right. So net field at point B, if you want to find out, then here this is bigger than this, so it will be E1 minus E2 and its direction will be towards left. Now suppose you want to find out electric field at point C. So due to this charge, direction of electric field will be along this line, and due to this charge being negative, electric field will be along this line. So you have two fields, both have equal magnitude, but they are at angle. You can check, is it 120 degree? How? This length, this is equilateral triangle. So definitely this angle will be 60 degree. So this angle is 120 degree. So you can easily find if two equal forces are, if two equal vectors are inclined at 120 degree, then resultant will be equal to either vector. The same thing will happen. So its magnitude will be either field, and then direction will be at 60 degree to any. So if we take this is 60 degree and this is 60, so what will it be? So this will be parallel to this line. So I think you have understood. Same thing is explained here. You can read and then you will tell. Same explanation is given here. Now we are going to consider electric field lines. So electric field lines are imaginary curves like magnetic field lines, and they start from positive charge and they are always perpendicular to the surface from which they are coming out. They can't intersect each other, and if there is negative charge, then they will enter in it, and they can't be closed loop, as you have seen that in case of magnetic field lines they form closed loop. And here also, if lines are closer, means denser line will indicate that field is stronger, and vice versa. So here we will see related concepts. Here field lines are shown. Field lines due to positive charge. Q is greater than 0 means it is positive charge. So field lines are coming out perpendicular to the surface. If if charge is negative, means less than 0, in that case field lines are entering. And if two charges are of like nature, means here positive are shown, then field lines will be directed like this, and there will be a neutral point where no electric field will be there, because the field due to both charges will get cancelled. And now we are going to find out electric flux. So what is flux? Electric flux means number of field lines. So we will study Gauss theorem, which will be used to calculate electric flux. So here, before starting electric flux calculation, we must know what is area vector. So if we have any area and say area is A, so we consider a perpendicular on it, and that is called area vector. Sometimes it will be denoted as vector ds, in which we will write ds magnitude and n cap. So it is always perpendicular to the given area, because you know that area is not a vector. Here this is just imagination that whatever area we take, we consider a vector perpendicular to it. So this will make calculation easier. Here our concern is to calculate the electric flux. So electric flux is denoted as phi. Phi is EA. Here EA cos theta we will consider later, but here we are taking just EA so that we can find the unit of flux. We can also write here phi E. In case of magnetic flux, we will use phi B, and that will be equal to BA. Although dot product E dot A, this is equal to E dot A. Perfect. So EA cos theta. And if theta equal to 0 degree, means electric field and direction of area vector are same, in that case theta will be, here theta is 0 degree means what? This is area, and area vector is in this direction, n cap. And if electric field is also in this direction, then what will be theta? Theta will be 0 degree. So here angle between area vector and electric field is denoted, not that of area. Area is like this. So electric field is also perpendicular in this case. So we have got the expression for phi, and we are going to make use of Gauss theorem to calculate the value of flux. So let's see what is that. So here we are taking phi E as EA over theta equal to 0 degree. And if we study about Gauss theorem and its proof, so we can get this value. So let's try to derive, although it is given after some more topics. So either we must not do it at this time. First of all, let's consider the concept given here, that is electric dipole. So what is electric dipole? So electric dipole, there is positive charge and there is negative charge, say plus Q and minus Q, and there is certain separation. So the charge must be equal and opposite. So here we can find dipole moment. Dipole moment, and that is given as P equal to 2AQ, where 2A is the separation between two charges and Q is the charge, and its direction will be from minus to plus Q charge. Here we are going to find out the field on the field of an electric dipole an axial point and equatorial point. So let's consider an equatorial point. So suppose we have this is electric dipole, say this is minus q, this is plus q, and there is a point from center, suppose distance of point P that lies along the same line here is say R, and this length is A, dipole length is 2A, so till midpoint it is A up to here. Now we have to find out the electric field at point P due to these two charges. For this, let's denote it as minus E minus Q. It means electric field due to charge minus Q, and its direction will be, suppose this point is A, this is B, this is C, so its direction will be along PA. So it will be given by Q upon 4 pi epsilon dot times what is distance? This is A, this is R. So it will be R plus A whole square, and direction we can write along PA. Now E minus Q will be Q upon 4 pi epsilon naught, and what is distance? So from here, this distance will be total distance from here to here is R, and this distance is A, so R minus A. So take it R minus A whole square. Since it is positive charge, so its direction will be along BP. Here, this is field due to positive charge. This is field due to negative charge. Now, net field. So, which one is larger? This is larger than this. So, net field will be sum of the two. So, here E plus Q plus E minus Q will be. But here directions are opposite. So, we have to keep this negative. So, Q upon 4 pi epsilon naught R minus A whole square minus Q upon 4 pi epsilon naught R plus A whole square. Now let's simplify. So on simplification, what do we get? Here, suppose E net, we write it. So Q upon 4 pi epsilon naught can be taken common. Then 1 upon R minus A whole square minus 1 upon R plus A whole square. This will become Q upon 4 pi epsilon naught. Then R square plus A square plus 2AR minus R square minus A square plus 2AR whole divided by R square minus A square whole square. I think you have understood. This is taken here, this is taken here, then I have opened the bracket, and because of minus sign, these signs are changed, and here A minus B whole square, A plus B whole square gives A square minus B square whole square. That is written here. R square will cancel out, A square will cancel out. So you will be left with a Q times 4AR divided by R square minus A square whole square. So you have found out the net electric field due to dipole. Now here certain other things can be done. So let's see what are those. So we know that dipole moment P is given by 2AQ. So 2AQ we can take from here. So 2R will be left. So you can write it 2AQ into 2R divided by R square minus A square whole square. Then 2AQ can be written as P into 2R divided by r square minus a square whole square. Now some more assumptions can be made that dipole length can be neglected. Dipole length is very less as compared to the distance of the point at which we are finding the electric field. In that case, we can say r square is greater than a square. Hence, we can neglect this term. So, what do we get? Then electric field will be P into 2R divided by R power 4. So 1R will get cancelled. So R cube. So it will become 2P divided by R cube. So you can say electric field due to dipole is proportional to 1 upon R cube. So this is one important factor, because if you remember, electric field due to single charge is given by Q upon 4 pi epsilon naught R square, that is, it is proportional to 1 R square. So this is the difference, and you have seen the resultant electric field due to a dipole on its axial point. Next concept we will study in next lecture. Thank you. Team Educate.